Hello world, welcome to TOC. My name is Abhishek Rajan. In this lecture, we are going to understand what is a functional interface and what are lambda expressions. There will be two subsequent lectures on this topic, so this is the first in the series. And in this lecture, we are going to understand what is a functional interface and what is a functional method. All right, the functional interface, functional method, and the function descriptor. All right, so this way we'll understand when we are going to write the lambda expressions. Okay, and we will understand the anatomy of a functional interface. Then we will understand what is a functional interface and at the rate functional interface annotation and why to use them, and then ways to implement a functional interface, different ways to implement a functional interface. And we'll get introduced with the lambda expressions and then writing lambda expressions to implement a functional interface. And then we will write lambda expression for different type of methods in a functional interface, and then finally we'll use lambda expression in a code. All right, you can see here in my editor there is an interface operations. So in this interface operations there is one abstract method which takes two arguments as integer. It takes two integer arguments and it returns an integer value. All right, so this interface specifies a single abstract method, so this interface should be taken as a functional interface. All right, irrespective of type of the method, as long as an interface has a single abstract method, that interface should be taken as a functional interface. All right, so and this interface is also called as SAM interface. All right. What is the meaning of SAM? SAM meaning single abstract method. So this interface is also called as a SAM interface. And the method inside this interface is also called as a functional method. All right. This method is also called as a functional method. Now let's talk about this annotation at the rate functional interface annotation. So basically, this is an informative annotation, all right, and it is recommended to use this annotation on the interface, on that interface which is intended to be used as a functional interface, all right, because when we add another method, any other abstract method in this interface, let's say I'm adding one more abstract method in this interface, int find list, int find list, int a, int b. So this interface has been annotated with this annotation, and this interface has more than one abstract method. Now let's see when we compile this code what happens. There will be one nice error, unexpected at the rate functional interface annotation. It says that this annotation is unexpected because it has more than one abstract method. So we are not supposed to use this annotation on this interface. So basically our intention is to use this interface as a functional interface. So we will remove this method from this interface. And when we will take a look in some IDEs such as I use IntelliJ IDEA. So this is the interface buffer reader processor, and on this interface has been annotated with functional interface. And when we add one more method in this int void int send, or I should say void send message, void send message. All right, so you can see here there is one compilation error. Okay, multiple non-overriding abstract methods found in interface. All right, so it says that this interface, this annotation is wrong. All right, using this annotation is not correct because it has more than one abstract method. All right, so on compile in IDE also we have seen that how this functional interface annotation is useful when we are supposed to use an interface as a functional interface. All right, now let's see some of the interfaces which has been added in Java 8 as a functional interface. All right, so this is the functional interface, that's consumer. All right, so it has the method, abstract method accept, which accepts an argument and it returns a void. All right, so this is one interface. And other interface, that is the functional interface, is the supplier. all right. It actually does not accept any argument and it returns some value, all right. And other is the predicate interface, all right. So it has the test method, which is the abstract method in this. So it takes an argument and returns a boolean value, and then the function, all right. The function is the functional interface, which has this apply method as the abstract method. It takes an argument and returns an argument which is not as the same type of this argument which it accepts, all right. So so apart from this, there were other interfaces as well which have been added in Java 8. But before Java 8 also there were some interfaces such as runnable, callable, and comparable, which were supposed to be the functional interfaces, all right. So now let us understand the anatomy of a functional interface, all right. So we can see here a functional interface can have a single abstract method, only one abstract method. Let me change the color of the pen. A single abstract method should be there in a functional interface. A functional interface can have zero or more static methods, all right, and it can have zero or more default methods, all right. So these default methods are the methods which provide default implementation for a method inside this functional interface, all right. So what we talk about this functional interface, it can be an interface which has a single abstract method, all right. And this functional interface is also called as a SAM, and this single abstract method is also called as uh, a functional method, okay. And a functional interface can have a single abstract method, it can have zero or more static methods, and it can have zero or more default methods, all right. So now let's talk about the Lambda expression. As we have to write the Lambda expression to implement this interface, the Lambda expression is uh, is a way to provide implementation for this method, which is the abstract method in this interface, all right. And this interface has one method, only one method, all right. So basically a Lambda expression is an anonymous function, all right. So what does it mean by anonymous function? Because it will not have any name. When we implement this interface, when we provide implementation for this method using Lambda expression, it will not be having any name, all right. So basically in order to implement the Lambda expression, we will have to understand the body of Lambda, all right. I mean, what all things are there in a Lambda expression? So you can see here a Lambda expression can have essentially a Lambda expression essentially have three things, all right. List of comma separated arguments, arrow operator, that is arrow token, it will be like this, a hyphen and a greater sign, all right. And the body of Lambda, all right. The comma separated arguments, all right. So what does it mean by comma separated argument? So let's say we have a functional interface. Let's say interface 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 operator operate operate, and in here we have something like void sum, and there are two arguments, int a, sorry, and it has two arguments. One is int a and the other is int b, all right. So these are the arguments. Now let's see how to write the Lambda expression for this, all right. So we can see here this interface operate interface, it has only one method, void sum, and it takes two arguments, integer variable a and integer variable b, all right. So when we have to write the Lambda expression for this, we need to understand that Lambda should be composed of three things. That's a list of comma separated arguments, that is a b, all right. So we have taken the comma separated argument int a comma int b, all right, we have taken that. Now it says we should take the arrow token, this is the arrow token, all right, we have taken it. Now we have to write the body of Lambda. So this is the place where the actual processing of Lambda takes place, all right. So basically basically we have to write here the logic for this lambda expression. All right, to implement this method. So basically, this is a sum method. All right, it returns void. Very well. So we are not supposed to return anything. Basically, we have to sum this value and print it. All right. So basically, what we can say, sysout a plus b. All right. So what it does, it takes two argument and it prints the value after summing it, after doing the addition. All right. Now let's try to write the implementation for this interface. All right, for this operations interface. So as we have seen, this lambda can have firstly, it should have the list of comma separated arguments. That's fine. So we are going to take the comma separated arguments here. Okay, so we took that. Yeah. All right. Now it says that it should have an arrow token then. Very well. We can take the arrow token. Now it says that the body of lambda, all right, the body of lambda, we came down and here we are going to write the body of lambda. So body of lambda meaning this is the place where actual processing of lambda takes place. All right. So what we can say? We can say we can say that as we need to find a greater value out of this a and b, so we can say that return a greater b. If it is so, then return a, else return b. All right, this is the logic for this finding greater value out of the two variables. So what next? All right, what we have to do further? Basically, this is the lambda expression which is implementing this interface. So basically, this lambda expression is the instance of this interface. All right. So what we can say, we can assign this lambda expression in the reference variable in any variable which is of this interface type. So this is what we have done. All right. So we have assigned this lambda expression in this variable which is of interface type. Further, what we have to do, we have to invoke this lambda. All right. We have to invoke this lambda. So in order to invoke this lambda, what we have to do, we have to call the method of this interface. So how we can call that? Ref dot find greater 10 comma 20. All right. So what we have done, we have a functional interface. We have implemented the functional interface using lambda expression. And what we have done to implement this interface using lambda expression? So what we have done to implement this interface using lambda expression, basically we understood what is lambda. Lambda is an anonymous function which has three parts. First is the list of comma separated argument. So we have taken the list of comma separated argument. All right. Now we have to take uh, arrow token. So we have taken the arrow token. All right. This is the arrow token. And then we should have the body of lambda. All right. So the body of lambda is this. This is the body of lambda which is enclosed inside a pair of curly braces, but that should be ended with a semicolon. Oh, this is the mistake we were doing. Sorry. All right. So this is correct now. And what we will have to do to invoke this lambda, basically we will have to call this method which has been implemented here. All right, we will have to call this method which has been implemented here using lambda expressions. So how can we call this? We can call this on this reference variable find greater. We are passing these two arguments for these two variables. For these two arguments, we are passing these values. All right. Now, why are we calling this inside system out println? Because it does not have any print statement and it is returning some value. It is returning some value. So we are calling this inside a system out println. All right, fine. So let us see how it executes. So basically, we are going to execute this. 1 second. Okay, it has been executed. There is no compilation. There is no compilation error. Now, what we said, out of 10 and 20, find greater. All right. So 20 is the greater value. So we have understood how to write the lambda expression for this method inside this functional interface. So this is the functional method. This is the functional method for which we have written the lambda expression. All right. So this is quite clear. Now there are some refactoring. Let's do some refactoring. All right. So basically there is only one method in this interface. So we are not supposed to write the data types for these variables. All right, because the type of these variables, type of these parameters will be understood as per the order of these variables. So we are removing. Why it is so? Because there is only one method. All right, and since this is an anonymous function, so and here there is only one method, and since this is an anonymous function, so we are not supposed to write the type of the parameters. All right, it has been removed. Now we can see here, since this is a one-liner, this is a one-liner, the logic what we have written here, it is a one-liner. So if for this one-liner we are not supposed to keep this inside a pair of curly braces. All right, so what I mean to say is we can remove this pair of curly braces. All right, so we are removing it. It has been removed. This also should be removed, and let's take this in the upper line. All right, and as we can see here, there is only one method. The return type isn't. So this return keyword is not required here. Okay, this return keyword will automatically be inserted by the compiler. All right, so it is not required. So it will be understood, even though the return keyword is not there, it will be understood that this is going to return some integer value. From here it will understand, and this is why I said what is what you, this is why I mentioned here in this image, we need to discuss this particular function descriptor. Okay, so basically what is a function descriptor? You can see here this interface. All right, so basically on this function, so this interface is having only one method. All right, and this method, what is this method? It is a method which accepts two integer arguments and returns one integer value. All right, so basically this signature of this abstract method, abstract method, it actually describes the signature of lambda. All right, so basically what I mean to say is, based on this signature, our lambda will be composed. Okay, when we understand how to write different lambda expressions for different type of methods in a functional interface, we will see that the function, the construction of the lambda expression, it totally depends upon the function descriptor, meaning the type of function inside this functional interface. All right, now let's understand how to write lambda expression for these interfaces. These are all the functional interfaces. All right, these are all the functional interfaces, and it has different methods. For this interface, we can see here this method is having two arguments, and it takes two arguments and it returns an integer value. So how to write the lambda expression for this? All right, so basically we know that this function descriptor describes the the signature of the lambda expression. All right, so we can see here, in order to write this lambda expression, we need to understand what type of argument it has. All right, because this we have to take as the left part of the arrow statement, arrow operator, or the arrow token. This is the arrow token. This is the arrow token. All right, this is the arrow token, arrow token, arrow token, and this is the body of lambda. All right, here goes the body of lambda. Here is the place. This is the place where the real processing of lambda takes place. This is the place for body of lambda. Body of lambda. All right, and here is the list of arguments. List of arguments. All right, so how many arguments do we have? This is A and B. We have discussed that the data types are not required here, so I am taking only the variable names. All right, and this is the arrow operator which separates the list of argument from the body of lambda. All right. So here we need to write this the implementation for this method. All right. So we should have some idea in our mind that what should be the implementation for this method. So basically, we can as this function interface, as it signifies that it takes two arguments. It has been taken. It returns an integer value. So definitely we can return something like a plus b. All right. This is how we can implement this interface. And what next we can do, we can assign this lambda expression inside a variable which is of this interface type. So we can say that my interface ref equals this. All right. Now, as we said, as we have understood that since this is a one liner, so keeping this inside a pair of curly braces are not required, so we can remove this from them. Okay, so let's remove it. So we can write this something like this. All right, my interface ref equals a comma b arrow operator or the arrow token a plus b semicolon. All right, so this is how we can implement this interface. Now let's see how to implement this interface. All right, so as usual we will have to assign assign our lambda into a reference variable of this interface type. So we can take that here, my interface ref equals, we have to take the list of arguments first. Okay, we have taken the list of arguments, and then the arrow token, we have to take the arrow token. Okay, we have taken the arrow token. Now what we have to say, we have to implement this method. Now it does not return anything. All right, so basically what we can do, we can simply sum these two variables and print it. All right, print a plus b. All right, this is how we can implement. Now let's take this interface and write the implementation for this. All right, so this is the interface which has a method which returns a boolean value and it takes an integer argument. All right, so how can we implement this? First of all, we need to write the reference variable of this interface type. So we can write that my interface reference variable equals, what we can say, first we need to take the list of arguments. All right, we have taken the list of arguments. This fine. Now what we have to say, we have to write the arrow token. We have taken the arrow token. Now what we have to do, we have to implement this method in such a way that it returns a boolean value. All right, so what we can do, it is an integral value, it is an integer value. So what we can say, we can check whether it is a prime or not. So what we can say, a mod 2 double equals 0. This is how we can implement it. All right, so now this method, how we can implement this method. Okay, one thing we can observe here, since this is a single argument. All right, this is a single argument, so it is not required to keep this single argument inside the pair of small brackets. All right, we can keep it free on the left side of this arrow token without any small bracket. Okay, so let's do that. So we have removed the small bracket from here. Now let's write the implementation for this interface. So how we can do that, this method takes a string argument and it returns an integer value. So what we can say, we can simply say that first of all, let's write the reference variable for this, my interface reference. All right, should be equal to, we should take this string argument first. So since there is a single argument, so we can take it without the pair of small bracket str. It returns an integer value, so we can say that we can return the length of this string. All right, so we can say that str dot length semicolon. All right. Now let's implement this interface. Okay. So this is an interface which returns some integer value. All right. So what we can say, we can say that we can return the integer value for this. So in order to do that, we can return summation of first 100 numbers. So for that, we can write the implementation. So how we can do that? My interface, ref equals empty bracket, and in here we have to write the implementation for summing up first 100 number or first 10 numbers, we can say. Sum equals 0. All right, so let's start a for loop. I equals 1, I smaller equal 10 plus plus I, and in here we can say sum plus equals I. All right, and here return sum. This is how we can implement this this interface. So as we have seen that we can write different implementation for this, for the functional interfaces for this different method, and here we can observe that the function descriptor is important to write the lambda expressions. Now let's talk about this last topic, how to use lambda expressions in code. All right. So basically, this is the implementation of the method of this functional interface, which is a lambda. All right. The beauty of this lambda expression is that when we implement an abstract method using this lambda expression, so that lambda can be passed as an argument to a method. All right. This lambda itself can be passed as an argument to a method. All right. So basically what I mean to say is wherever this interface is expected, all right, wherever this interface is expected, we can pass this lambda. All right, either we can pass this reference variable or we can pass this lambda. All right, so this is what we have to demonstrate now. So let's take a look here. What we are going to do, we basically have an interface, all right, which whose implementation finds which one is greater, and now we have to write a method here. Now we have to write a method here, meaning we can say that it should be public int uh, is even, and it takes argument of this interface type, and it takes two arguments, a and b. All right, so what it does, it finds out which one is greater by calling this method on this operations, and checks it checks whether the greater value, whether the larger value is even or not. So basically we should return boolean here. All right, so let's do that. So basically what we have to do, we have to call these operations. So basically int result equals operations, and call this find greater. On operations, call this find greater and pass these two values, a comma b. And further what we have to say, sorry, what we have to say, result mod to 0. This is what we have to check, because we have to find out whether it is even or not. So for that we have to call this method from here. So what we are going to do, basically we are going to call this inside system out println, and in here what we are saying, so basically we have to create object of this, and on this object we are calling this is even, and we are passing this ref and some values 45 comma 55. All right, so this is what we are doing. So what we have seen, we are calling this isEven method on the object of this class. This is the object, and on that object we are calling isEven method. And since this interface is expected here, so we are passing this reference variable here and passing two values, 45, 55. So it is going to check the larger value is even or not. So let's execute this. So it is false because 55 is not an even number. So let's check for 60 and 55. So it should come true this time. Let's save it. So see, it is true. So basically, as I said, we can pass the lambda. Wherever this interface is expected. All right. So what we can do? Let's remove first this data types which is not required. All right, and we can pass this lambda here. We can pass this lambda instead of reference here. All right. So let us pass this lambda. This is not required actually. So we can keep it like this, and let's block this. Okay, so I have blocked this. Now let's execute this. See, it's working. All right. So this is how we can. So we can change the implementation here actually. It comes in line, so we can change the implementation here. All right. So this is what I had to discuss in this lecture. I have uploaded second part of the lecture. You can find the link in description. Please view the second part of this lecture as well, so that you can understand the complete. You can have the complete understanding of lambda expression. So thanks for watching. Bye bye.